Hi to all. In this video, we are going to see about electrical machine design 18EE55 Module 1 limitations in design. Okay, for the every machines, some of the limitations will be present. Okay, here we are going to see the but saturation, current density, temperature, insulations. Okay, these three things: saturation, current density, and insulations. Okay, these three things are major things for every design limitations. Okay, let us consider. Okay, the materials used for the machines and other such a cooling etc. The materials used for the machine and other such as cooling etc. imposes a limitations in design. The limitation stem from saturation of iron, current density in conductors, temperature and insulation, okay, mechanical properties, efficiency, power factor, etc. First one, saturation. Okay, the high flux density reduces the volume of iron, but drives the iron to operate beyond knee of the magnetization curve or in the region of saturation. Saturation of iron possesses a limitation of account of increased core loss and excessive excitation required to establish a desired value of flux. It also induces harmonics. Okay, in this saturation is nothing but if we apply that more mmf also, magnetic motive force also, the flux path generated, suppose a person can eat uh, one plate of rice. If you give three plates or 10 plates of rice, also only he can take only one plate of rice. Okay, that other 9 plates or saturation are not able to use by the person. Same way, saturation is nothing but higher flux density reduces the volume of iron, but drives the iron to operate beyond knee value. Okay, so of the magnetization curve or in the region of saturation. The saturation, if the magnetic curve works in the saturation, it will be a useless. It cannot be used by the machine. Okay, only that curve, magnetic curve, the that flux in the magnetic curve one will be useful one. Okay, so saturation or iron possesses a limitation on account of increased core loss and excessive excitation required to establish desired value of flux. It also introduces the harmonics. Okay, unnecessary things. Second one, okay, limitations in design. Current density. Okay, higher current density reduces the volume of copper but increases the lower losses and temperature. Okay, higher current density in the sense a small space, if you add more number of conductors to carry the current, okay, that is called higher current density. Higher current density reduces the volume of copper because a small place we are going to give more current, but increases the losses and temperature. When the current value will be more in particular area or particular conductors, what will happen, that temperature, if the current will be more, the temperature also increases in the copper conductors. Then what will happen, obviously the temperature increases, the losses on the system or losses in the machines will be increased. Okay, so it may leads to damage the machine also. Okay, so the higher current density reduces the volume of copper but increases the losses and temperature. Third one, we'll go for temperatures. Possesses a limitation on account of possible damage to insulation and other materials. Okay, the temperature rise should be in a range. If it goes beyond that value, what will happen? The possible of damage of insulations and other materials. Suppose if any fault occurs, if any temperature increases in the rotor itself, okay, that copper that insulation peels, because of that short circuit occurs and it damages the whole machines. Fourth one, insulation. Okay, insulation which is both mechanically and electrically weak. If the insulation mechanically and electrically weak, suppose if it is a motor or generator, that rotational force will be present, um, and it should be a it should the machine should withstand the centrifugal force. Okay, like that, it's a mechanical one. Okay, and insulation with both mechanical and electrically weak. Suppose we are generating the voltage of um, 13 kilovolt. There the insulation should be capable of uh, withstand the particular voltage. If it is not withstanding that, what will happen? That insulation breaks. When the insulation breaks, that current takes the short, that is low resistance path. Because of that, that machine itself damaged. So which is both mechanically and electrically weak. Okay, that's the limitations. Okay, possesses a limitation on account of breakdown of by excessive voltage gradient, mechanical forces or heat. It has to be so. The insulation should be capable of um, electrical, that is voltage and current withstanding capacity. And then there it should be, if it is a transformer, if it is a motor or generator, that centrifugal force will be act. That force should not be affected, like that. It should be mechanically strong, that insulations, and heat, it should not transfer the heat from one, like stator to rotor, or in the rotor itself, one rotor to another place of rotor. Okay, it should be withstanding the heat, it should be withstanding the mechanical, and it should be withstanding the electrical fields. Okay, mechanical strength of the material possesses limitations, particularly in case of large and high speed machines. Okay, this one is normally we go for higher value of motors and higher value of generators. Okay, the the mechanical strength should be good. Okay, it should not be weaken one. Okay, because higher value of machines, the value of weight of the machine also very high, and the forces, like centrifugal forces are acting on the machines also very high. Okay, the mechanical strength of the materials possesses a limitations, particularly in case of large and high speed machines. Okay, next one, high efficiency and high power factor possesses a limitation on account of higher capital cost. Okay, so if you go for a machine with higher efficiency, that capital cost also will be increased. So the machine should be chosen that it has to give good efficiency. At the same time, the cost of the machine should be low. A low value of efficiency, efficiency and power factor on other hand results in the high maintenance cost. Okay, when you go for a high value of machine, the maintenance cost will be reduced. At the same time, if you go for a low value of machines, that time the value of maintenance will be very high. Okay, to avoid that, we should go for a moderate machine. It has to give good efficiency. At the same time, it has to be maintenance, less maintenance. Okay, like that the machine should be chosen. Okay, mechanical communication in DC motors or generators leads to poor commutation. Okay, mechanical commutation is a DC motors or generators leads to. Apart from that, above factor consumes manufacturer standards specifications may be possess limitations. So the machine, that current density, temperature, insulation, saturation, these are the things will leads limitations in design. So when we design a machine, these are the things we should take care, as well as we have to follow the standards, uh, like BIS standard, BS standard, okay, ISO standard. That machine should satisfy the standards which will be framed by the government of national